Hi, boys and girls. I'm here today at the Fayette County Public Library with a show called Science Isn't Scary. All right, guys, we have some really simple concepts that I want to teach you through this program. Today, we're going to be talking about energy, and energy is what gives us the ability to move and do work. Now, sometimes your teachers at school may put words on the board or tell you that you're going to be working on some concept, and it seems so big and scary. But on this show, I'm going to teach you some very simple ways to make science more understandable and less overwhelming and less scary. So, we're going to be talking about energy today. Scientists like to break energy into two different categories. We have the energy of motion, and we know that when we have motion, we can do work. There's also the energy that is just stored up and it's waiting to be used. It's one of the reasons that we sleep at night, so that we will be able to gather and store up energy so that we can use it during the day. Well, your teachers may tell you that you're going to be working with kinetic or potential energy, and those are big words, but it's really not all that hard. Kinetic energy is that energy of motion, okay? When you are moving and when you are doing some actions, you have kinetic energy. When you are still and you have the potential to move, you have stored up energy or potential energy. I'm going to show you a really neat little craft that we're going to make today that can show you both kinetic and potential energy. This is a catapult, boys and girls. A catapult was used in ancient days to launch missiles up over a castle wall so that the enemies could be defeated. We are going to make a little catapult, and as you can see, all you need is some rubber bands, some of these big popsicle sticks, or like tongue depressor craft sticks, and you need a launch bucket. We've used our milk lids, or this is an orange juice lid, as our rock bucket. Now, if you don't have these items at home, you can come here to the Fayette County Public Library, and I've made little packets for you so that you can make your very own catapult and practice playing with kinetic and potential energy. All right, all you need to do is take 8 of these popsicle sticks and lay them on top of each other. You need some rubber bands, and if you can't wrap it around like this, you may need to get an adult to help you, okay, and wrap them all around one end. Then you're going to slip one popsicle stick in between those two and take your rubber band and fasten that on the other side. All right, you're going to want to have that in the center. You're going to take your other, where you've put your lunch bucket. It is best, boys and girls, to use hot glue. So you might need an adult, okay? And I've really glued it well to the back of that, because if you really play with this hard, that lunch bucket may come off, and then you'll have to glue it again. So now we're going to lay these two on top of each other, and we need to rubber band this end together. So we're going to rubber band here. Okay, don't do it too tight that it breaks. Okay, and now we're going to slide those popsicle sticks down to the end. So you can see that we've got this little springy action going on at this end. You can also take your rubber band and go crosswise in here, and that will help hold it just a little bit more so that your energy goes all to the launch bucket. Now, what we're going to do here is launch some missiles and show you how kinetic and potential energy work. Now, don't you know, boys and girls, that math and science both work together? And so when we are going to do this, we're not just going to play with it, which it's okay to do too. If you want to draw a big X on the floor and launch some missiles and try to hit the center of the X, that's really fun. You could draw a castle wall, try to hit the different parts of the wall. That's a lot of fun. And that's just play. But today we are going to do a little experiment. And with an experiment, we need to use some math. We also need to come up with a hypothesis. That's another big sort of scary science word. But a hypothesis simply is a guess. We need to guess which missile I'm going to use on my catapult is going to go the farthest. All right, so if you look at my setup, I have my yardsticks. I have 2 yardsticks lined up side by side, so we have a total of 72 inches. Boys and girls, do you think my missiles will go that far? Let's see. I hope you're making a guess. I have several missiles that we're going to use today. I've got some ping pong balls. I've got some foil balls. I've just took a strip of foil and wadded it up. Got some cotton balls. And I was like, I need one other thing. Let's just use some dice. Okay? So these are all missiles we're going to use. Now, back to energy. Let's look at our catapult. When you depress that, and that motion going on right there is some kinetic energy. When you're just holding it down, it is stored up energy. It is potentially able to move. When you let go, it's moving again, and that is your kinetic or your moving motion. So that is the way that catapults show both types of energy. Now, let's get started. Boys and girls, have you made your hypothesis? Which one of these missiles are going to go the farthest? Let's start with the cotton ball. It's the lightest, and you probably are thinking, it doesn't go very far. It's too light. Well, let's see what happens. We're going to put it in our launch bucket. We're going to press it down and let go. And there you can see it went almost a whole yard, 34 inches. I'm going to mark where it is so that we can find the average amount that these go. Now remember, with a good science project, you can't just do something once and assume that's the right answer. You can't make a conclusion from just one try. So we are going to try it 3 times. Cotton ball number 2 into our launch bucket, depress, and let go. All right, that one didn't go near as far, did it? Okay, so that one went about 28 inches. And we have one more try, just so we can get an average of how far a cotton ball will go in this type of catapult. All right, we're pressing it down and letting go. And again, it didn't go very far, did it? So you can visually see where our 3 cotton balls went. Let's try our foil balls next. They're very light. So boys and girls, what do you think? Are they going to go as far as a cotton ball? Let's find out. Okay, into our missile launcher it goes. Going to depress it. Now it's got stored energy. It has the potential to move, and boom! There it goes. Now I'm going to use another color. Now we need to mark it where it landed, which was about right here. Already you can see with the colors that it went a little farther than those cotton balls. All right, here's our next foil missile. We're going to depress, and boom! All right, it went almost exactly where that other one landed. Let's try one more time, because remember, you have to have at least 3 trials in order to get a good average. I'm going to hold our catapult down, depress, and boom! All right. So you can see between the 2, boys and girls, which one on average went farther. Well, the orange or the foil did. All right. Our next one is our ping pong balls. Okay, again, these are very light, but they bounce. And now remember, with these, actually, they're going to bounce and bounce and bounce and bounce. And that's another type of energy called inertia. Okay, so inertia is a special energy law that says something's going to keep on moving until something stops it. Or it's going to just stay still until something moves it. So these ping pong balls might just keep bouncing, 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 bouncing until they go off the table and maybe just land on the floor, and that carpet is going to stop its motion. All right, so let's see what happens with our ping pong ball. And launch! Oh my goodness, it didn't go far at all. I am surprised. It only went right there. All right, when I tried it earlier, it went so much farther. Let's try again. Maybe it's not far enough down. All right, ready, go. Well, I am surprised, boys and girls. I thought for sure these ping pong balls would go further. We have 2 of them right there. One more try. Let's see once. Maybe our foil is going to be the winner today. And boom. Yep, look at that. They almost went the exact same spot all 3 times. That's amazing. Huh. That's interesting. That's not what I did earlier today. All right, let's try the dice. I'm going to put it into our catapult and launch that missile. Did we see where that one went? It didn't go very far at all, did it? Even though it's heavy, it didn't go too far. One more time, and boom. Oh my goodness, it only went like 10 inches. And one more time. Our final trial. Oh my goodness. All right. So you can very easily see, without having to actually do the math and add up all of the inches, the little Post-it notes help you visually see where everything landed. And if you're looking at them, you can tell that our orange definitely went the farthest. And that is our little foil balls. All right. So boys and girls, today we learned a little bit about energy, a little bit about catapults. I hope that you had fun, and if you want to make one of these, come get a packet. Science is not scary, and that's what I'm here to help you with. Every Tuesday, this is Tuesday, every Tuesday at 2:30, I'm going to do another little tiny demonstration to show you that science isn't scary.